and yeah, you might do, because Isaac, that's on after me, will be teaching you all about F# and the magic. Yeah, so F# is supported. I personally just stick to C# because the programming is hard enough without then taking an object-oriented programmer and throwing function at them. I do like it, but yeah, I just tend to stick to C#. But we've talked about it for long enough. Let's write some code. Who doesn't like writing code, right? So let's leave out of this. This is where we check the AV works right. Come on. Desktop 3. That one, yep. So, I'll zoom in a bit. Nope, not that one. Can everyone at the back see that code all right? Cool. So this is a out-of-the-box project. If you created a blank Xamarin Forms project, as it's called, as your project template, this is the project that would come up out of the box. So if we just have a look at the project structure. So has anyone in here ever done any native development before? OK, a couple. So if you've ever done native in either iOS or Android, this folder structure will actually look quite similar to you. So when you create the project, depending on whether you made it on Windows 10 or Mac, you'll have either the shared project up here, Android and iOS, or you'll also see UWP. But this was made on a Mac, so there's no UWP. So I'm going to do this in reverse order from the bottom up. So iOS, as I mentioned, if you've done native development before, you'll see what you'd expect. So you've got your info.p list, which just says things about like the app version and the name of it and things. Entitlements is like permissions. So it might be that you're writing an app that says, hey, I need to be able to take a picture. I'm sure if you've got an iPhone, whatever, you've seen the pop-up that says X wants access to this, you want to click OK. So that's where entitlements come in. Then you've just got other bits like app delegate and then main, and main says go off to the app delegate, and then the app delegate calls in here. So normally, if you're doing native development in either Objective-C or Swift, you'd see actual code in here that does more than what this does. But because it's Xamarin Forms, it's just saying, hey, initialize Xamarin Forms for me, and then just load the application, which is a new app, which is a Xamarin Forms app. So iOS and Android still need to know where to start, but all it's saying at the start is, hey, we're not running it from this project. Go and look here for what you want. So a lot of the time, you don't spend ages in your iOS or Android or sort of platform-specific code, as we call it. And then Android, you've got the main activity, which, again, if you've done Android before, would look familiar. Very similar, it's just the usual onCreate that you get on Android, and then it initializes Xamarin Forms and says, like before load application, hey, go up here to our shared project and have a look what to do. So let's close it off. iOS, cool. So we have our main page here that doesn't do anything. We're going to make it do something. So like Jim, Jim likes to keep fit. Jim plays basketball. He goes down to his local courts, and he likes to score some hoops, whatever it is the Americans say. I'm a Southern British person. I can't even attempt American. But we're going to make a counter app because it's useful for things, keeping score of the baskets you've scored. I don't know, or useful things. I'm a developer. I don't know sports. OK, so this, as I said, it's XML-based because it's XAML, so it will look a bit familiar with like the XML decoration at the top. Content page is just a type of page that stores content in Xamarin, as you'd imagine. And then we've just got XML namespace decorations that we can reference things. So in Xamarin, you have different types of layout. So you've got stack layout, as you see here, which means that everything's put in a stack. So the first thing you declare, in this case, we've just got a label, but you have a label, then you have the other components in a stack. Or you've got grid layout, for example, which, as you'd imagine, sets things out in a grid, so you can specify rows and columns, not just a number of them, but height, width, whatever applies, and you can start laying things out like that. Then there's also relative layout, which puts things relative to each other, but it's maths, and I just go, and run away. But stack layout and grid was a good start. So for our counter, we're going to stick with the stack layout, because all we need for a counter is a number of what we scored. and the button underneath. So we can change this. We can just cheat and take this already. We're going to say that we want this in the middle. So all this is saying is just stick the whole thing in the middle. So it's not one individual piece in the middle. We're saying that we want the whole thing in the middle. So we've got our text. We don't need any of that because we don't want it in the middle. There we go. We're going to set the color. Who wants to pick a color for me? Bisque, okay.
Because I don't know what color that is.
Well, we're going to find out, aren't we? Just makes me hungry, to be honest. I'm glad pizza's on after this. Lobster soup, yes. Okay, we're going to set the font size as well. So, because it's XML, it's all based with attributes, so we can give it different attributes. In this case, we've given it the text that we want it to display, the color of the text, and now the font. You can put, point numbers in here for font size, but I recommend against it. If you just use these name sizes like this, so it was large, small, medium, micro, I think, and some other ones, I recommend using those because then you don't have to worry about how it will look on, a screen double the size or half the size, because it just scales naturally because it knows how to handle it rather than being a specific size. So we're just going to say we want it to be large. And then we're just going to give it a name. So in this Xamarin Forms XAML, you've got attributes and you have X attributes. In this case, we're going to use name. So this is just that we can refer to it later, because as we update the value, we kind of want to know about it. So we're just going to call this counter label. Simple enough. So we've got a label, but we need a button that actually says, hey, do more. So let's put a button in. Again, we want some text. I scored. Why not? Make this medium. Sure, we're going to make it pretty. We're going to do, not doing fuchsia. So I cheat. So I stole this. Well, I say stole it. It's a hex value, so it's hardly stealing it. But he's a principal program manager now on the Xamarin team, David Ortonau, who always uses CC 0000, and it makes a really nice shade of red. So I'm stealing that. So we're going to. Dark red is one of my favorite colors for buttons. I don't know why. If you're in my talk on Thursday, you'll also see that I've got a red button. So we're just going to do text is white. Ooh, no, not wheat. That might look terrible. And some people might be allergic. My jokes are terrible. I'm really sorry. I'm not even a parent, let alone able to be a dad to make dad jokes, but they're just unending. So the other thing we're going to do here is do clicked. So all clicked is doing, as you'd imagine, is saying when I hit this button, what code are you going to look at to handle what happens? So at the moment it's going to moan because it doesn't exist, but we will write it in a minute, trust me. So we're going to go into so I never went through the shared code itself actually. So you've got a XAML file here. So this is where you'd have application resources. So, for example, if you've done web development, you might be used to CSS style sheets. All right, they're more of a sort of what it should look like. And Xamarin Forms does support CSS files now for some styling, although a limited version of it. But basically, if you want to do things like a resource dictionary, which is setting application-wide things like styling or colors and things like that, that's where that would go. But the main one that's of interest, don't worry about that, is in here. So every XAML file that you get with Xamarin Forms when it's being used to declare the UI is sort of in 2 bits. So it's part of it is the XAML file itself, and then part of it is this partial class that we call the code behind, which is always the name of the XAML file, .xaml.cs. And it does a couple of things. So the first thing it does is initialize components. So that's just initializing all the components in our Xamarin app. Then it sets the main page. So it's really tiny. You probably won't be able to see that, but it says gets or sets the root page of the application. So that's saying when the app starts, this is the page I want you to show first. So when you create a new project, main page is the first is the first page it creates you with the template. So you might find going forward that you want a different page. So it's useful to remember that because sometimes you forget to change it and then you wonder why your app's not doing what you expect. But we want the code behind for our main page. So all it does at the moment is components. So we're going to go ahead and do something with it. So we want account. Seems pretty straightforward. And then I think we call it increment counter clicked, I think. I probably should have copied that. Let's have a look. Yes, there we go. And then that's going to take two things, which is the sender. So you put it as an object, but sender is basically what component has called that method. So in this case, it'll be a button, but it might be something else. So you might want to leave it as object, but then you know what it's going to be, so you cast it inside. But in this case, we're going to leave it as object, and then we want... I went to get this butterfly keyboard fixed at the weekend, but Apple were like, it's going to take a week. We can give it back to you on the 2nd. And I was like, no, I'm going somewhere. I can't be dealing with this. There we go. Event args, there we go. So this is just a simple declaration for what a clicked handler method would look like in Xamarin Forms. So all we're going to do is we're going to say that count goes up by 1. And then we're going to say that the, what's that complaining about? Oh, don't need to be. So then we're just going to set, we call that label, didn't we? So we called it counter label, I think. Just double check. Ooh, let's capitalize that. Don't know why I put lowercase. There we go. So counter label.text is going to be equal to count. So all we're saying is that every time you click the button, it's going to be count to string. There we go. So we want it to be letters and obviously not numbers. So what will happen is it'll go up by 1 and it will update the text. So we've written this. All we've done is written some XAML code that has a button and a label and then some code behind that just says when you click the button, do this. But we can make it run in multiple places. So if we right-click on the solution, go to options. One of the things that I learned, which is pretty cool, which I've already got set up, but I'm just going to show it to you, is this idea of configurations. So if you right-click on the solution, go to options, under run, there's configurations. So traditionally, when you run a Xamarin app, you target either iOS or Android. But then that means that if you want to check how it looks on both, you've got to run one up, stop it, and then go and load the other one. And that's hassle. So what you can actually do is set up run configurations that you can target multiple platforms. So you can actually say, hey, load both. So that's just a little trick that I learned that I like to share with people because it saves you a load of time. So I've got sort of for those that understand the reference, Blue Peter style, here's what I prepared earlier, one already set up. So if we just click run on that, what that should do is build a project with all the native tooling and everything underneath and deploy it to an iOS simulator and an Android emulator. And my money's on iOS winning, but it might show me up, so we're going to find out. I'll wait for that to build. Anyone know any good jokes? Nope. I sometimes do a dance, but not today. I left my tap shoes at home. So it's just installing. So just wait for that. There you go, I was wrong. Android wins. I think it's because I had the emulator already running. So if you've ever done iOS or Android development before, or you have a rough idea of what the sort of basic UI looks like out of the box, you'll see that apart from the changes to the button I made, this looks and feels identical to even if it was made with Java or Kotlin, or when we ran the iOS version, Swift or Objective-C. Once you give this app to somebody, it's been made in exactly the same way. The developer might have used Xamarin to write it, but the actual building and everything has been identical, so you never know how it was created. Okay, so I forgot to line it up. And do you know what? We're going to change Bisque, because apparently Bisque is a very, very pale colour, and you can't see it. But this might give me opportunity, if this project's up to date enough, to try out a funky feature called Hot Reload, which allows you to actually update your XAML without having to stop and restart. It will just, as soon as you save, it will update the UI. So let's find out if I've updated Xamarin Forms enough on this. Because it... Purple. Which one will do? Purple, okay. I thought you said Rebecca Purple. I thought it was a shade of purple. I got confused then. Blame Google. It's not their fault, but I'm going to blame Google. Okay, so we're going to do purple. So if we save that and go back to our... No, I didn't update it enough. Okay. I will show that one later if we have time, because it's that feature, because it's cool. But let's just quickly run this again. Just so you can actually see it's there. It's not aligned properly, it's too far to the left, but you'll be able to see that it is actually doing what we expect it to do. Let's quickly wait for that to build. I did know some good jokes, but I've forgotten them now. It's actually important. There we go. Right, we'll do iOS this time, just so that you can see that it's the code's running on both. Which one's it going to run on? Let's change to... There we go. Okay, so that's in purple now. As you can see, the button's in the middle on both. The text is purple. It's wrongly left aligned. It's not big enough. But that was written once. Code everywhere. Deploy everywhere. So we click that. As you can see, even though it's tiny, the number is going up. Woohoo! In just a few minutes, we have our first app running on a simulator. So that's C#. But as I mentioned, it also supports F#. So I did a true Blue Peter style. No, wrong one. No, let's get the right desktop up. Mac likes to rearrange. You arrange the desktops in one order, and then it brings them up. So ignore that one. So it's bigger and zoom in. Don't worry. So this is the same counter app, but written in F#. It uses the Don Simon created library, or Don Simon team created library that you'd expect. And so the XAML mostly looks the same. So you've got bindings, which is a whole concept that binds properties together. So if one updates, it updates the other. And this is all part of the fact that F# uses this model view update architecture. And so things are bound together to do a state. So we've just got the same XAML. So very slight different syntax, but on the whole, you've still got the same XML-based layout. And then if we go into the actual F# itself, as I mentioned, it uses this whole MVU idea. So the model holds the state of our application. So in this case, it's the count. Then message just says what you can actually do with this application. So in our case, it's increment and decrement. We initialize it with a count, like we did in the C# version. And then every time you call update, which is obviously part of the MVU framework, then you just say count +1 for increment, or if you're calling decrement, then it's -1. Then it just links them up together so that the UI and everything's linked to those properties, so it works as you'd expect, and then you run it. So again, if we just run that quickly on the iOS simulator, excuse me, the colors are different and it's lined up better. But again, you have an app out of the box written in multiple languages. Now, what's cool, you can see here, as I mentioned, because it is the native tools and components, everything looks the same. This is a default iOS button, clear background or transparent background, blue text. So yeah, we've already got, in a few minutes, all right, one of them was here's what I prepared earlier, but in a few minutes we've got 2 apps written that run on multiple platforms with the same code base, and yeah, it was a piece of cake, and it was in multiple languages, which is pretty cool. So we will, cool, let's go to here. So now you've seen something pretty simple. Let's talk about something more interesting. Ooh, let's get rid of that, there we go. So we've got a counter app, but we can do so much more with it. We can do really cool things, more than just clicking a button and making a number go up. So one of the things I really like is cognitive services. So it's not specific to Xamarin, it's a Microsoft product around machine learning. So let's just read the spiel first of all. So I took this off the Docs website at the time of writing. So it says Microsoft Cognitive Services, formerly Project Oxford, are a set of APIs, SDK, and services available to developers to make their applications more intelligent, engaging, and discoverable. What does that even mean? So what it is really is that machine learning and stuff is hard. We don't all have a PhD in mathematics and all the things needed to train a million models and understand what's happening. So Microsoft have gone, do you know what? We can make this easier for you. Come use cognitive services. We'll make it as easy for you as possible. You just have to install some libraries and get started with it. So I'm just going to quickly change desktops again. We're going to go to the internet. Let's zoom in again. Oh, I hate when it does this. Hang on. Let's just... Stop that. Now it should switch. Let's have a look. There we go. Can everyone see that all right at the back? Cool. So I won't spend too much time on this page because I share a link at the end if you want to sit through this in more detail. But cognitive services is just a set of products from Microsoft that fall under a few categories. So you've got things around computer vision. So rather than you having to give it a million photos or something and say, hey, this is what this is, for a lot of things it already knows. So you can start doing things with getting information from images because Microsoft's done the work to kind of train it up on what these things are. You can also do face detection, ink recognition. So that's just the stuff that falls under their vision APIs. Then you've got speech. So it can also do things like speech to text, speech translations, speaker recognition, which is quite clever. If you're in maybe you're recording a panel at a conference, for example, and then they'll be able to start recognizing who's who for maybe doing things like live audio transcribing. And then you've got language as well. So that's text analysis. You can evaluate sentiment. And then there's other bits. There's search. As I said, I won't spend too long on here. We could spend ages because there's loads of things. But the main things that we're going to talk about are vision and language. So I'm going to tell you a story. It's a true story. You can ask the people that were there if you don't believe me. I'll tell you where to find them. A couple of summers ago, I went to a friend's house to play a board game with some friends from work. It's not your average board game. It lasted 12 hours. And it was good fun, and it was complicated. And one of the things it involved was trade and bartering and things that they called promissory notes. It basically meant you had one each game that you could give to somebody, and you could get them to leave you alone instead of raid you. So one of my friends was sat right next to me, and his spaceship was next to me in battle. And I said to him, I was like, I'll let you have, he was with, he had like a, faction class, whatever from video games. That meant he didn't research technology very quickly, so whereas my class did. So I said, hey, I'll give you the next tech I learn if you leave me alone. All he did was shake his head at me. Yeah, I thought he was agreeing to leave me alone. No, it turned out that's not what he meant at all. And I was raided a few rounds later and almost dead. Now, the reason I'm telling you this story is because it made me realize that I can't read body language. Not really a surprise as someone on the autistic spectrum, but I spent a lot of time watching House and Lie to Me and all those shows that try and teach you these things. But I wanted to I learned about cognitive services, and I thought, do you know what? I can probably find a solution to my problem here. I'm terrible at reading people, but maybe, just maybe, I can learn if I just, try it out. So one of the things I actually did was create an app to solve my problem. And I'm going to show you it now, actually. So we might need the internet for this. So let's see how we go. Where's my box? Dylan, did we ever find out what the password was for the Wi-Fi?
No. Does anyone know the password for the NDC Wi-Fi?
Okay. Yeah, we forgot to fix it before. That's my bad. Sorry. Where's the internet? It's connected to my phone. So lowercase L, capital L. London 2020.
That's called information security, what we just did there.
Yeah, but no one says we can't reset it afterwards. There we go. Okay, so I'll just connect my phone as well, and then I'll be able to screen share. Just because I want to show you this, because it's pretty cool. I know it's almost pizza time and you might be hungry, but this is pretty cool. It's not the prettiest app I've ever made, but I'm still proud of it. Not that I really make pretty apps at all. I got excited because one of my talks that I give, I discovered that you can make animated backgrounds in PowerPoint for Mac, so it just scrolls through space. That's about as good as it gets. There we go. So I'm on the same Wi-Fi now. So if I just share my screen quickly. If it lets me. This is where we find out firewalls and proxies are like, nope.
You have to remember that Troy Hunter's in the building, so they'll have locked down absolutely everything.
Oh yeah, that's true. Okay. At least I've had Dylan's permission to blame Troy if this doesn't work. It's all right. I've got a great story for Troy. I can't tell everyone, but I've got a great story that he's going to really appreciate. Basically, it's a story behind why all of a sudden at work I can no longer access Gmail or anything useful. Nope, it's not showing my screen. That's annoying. Okay. We'll just have to take my word for it.
Pretend it was amazing.
Okay, well, I can show you. I updated one of the pictures that's in a later slide just this afternoon, and it was using this app, so I can show you that. And we can always just eat pizza, and I can just show you, and we can just pull silly faces. But what the app does is, so I can do it. I can run it locally for the first bit, actually. So let's do it on here. So this app does two things. The first thing it does, which, well, it's the sort of the less exciting of the two things that it does, I suppose, is sentiment analysis. So sort of with the whole fresh in my mind thing that I can't read body language, I actually went to Microsoft Build in 2018, and I went to a talk by a friend of mine where he was talking about sentiment analysis with cognitive services, and he had this example text about analysing a pretend text from his boss. And I thought I knew what it, I thought I picked up the sentiment from this message. I was wrong. So I was like, you know what, I'm going to have to analyse text as well. So we're going to enter some text. I love NDC. Who doesn't? So what that's done is straight away it's gone off and analysed the sentiment of that and come back singing. I mean, okay, the singing is me. I'm not going to sing for you. Wait till Thursday and Dylan will do that. But yeah, it's gone off and it said, okay, we've decided that it's something positive, so we're going to sing at you and I'm going to put the text in green. If we change it to something bad, I don't mean this, I hate NDC with my double E because my butterfly keyboard's broken. There you go. It changes to be something, it picks up that it's negative. Now, as you'd imagine, because it's a computer, it can't pick up on sarcasm, so that very sarcastic sucks to be used because I'm a sarcastic, rude word, not because it can pick it up. But it's just something to be aware of, that it can't pick up sarcasm. So that's pretty cool, and if it doesn't know what it means, it won't do it. So this next bit I can't show you, but you just have to take my word for it. If we click Analyze Body Language, this will fail because iOS simulators don't have a built-in camera, but you can take a photo, it will go off, it will analyze the sentiment in it, with it giving you a score out of 1, which is kind of a probability score of a certain range of emotions, which I'll show you in a sec. And then, yeah, there you go. Based on a picture, it will tell you what the most likely emotion is. How does it work? That's the fun part. It's all well and good showing you that you can do these things, but how does it actually work? So if we just go back to here. There we go. So we've got the views. The main page is just the menu that you saw with the two buttons. Then the analyzed text, as you'd imagine, is just a label, an editor, a button, and then the result text. And then the body language page, what it does first of all is it's set out in a grid. So you've got an image. So when you take the photo, it gives you a preview of what the photo looks like. Then it says you're welcome to play with this afterwards, so you'll be able to see that I'm telling the truth. The button at the bottom, and then when you take the picture, when it's thinking about it and going off to do the analysis, it just brings up an overlay with a spinner, like you'd expect, and then takes you to the image result page. Ooh, Siri's picking me up now. An image, so it just displays the same image again, so that you've got a reference point and then how it works, sort of the description underneath. So how's that put together? So this uses an architecture called MVVM, which is model, view, view model. So a bit like MVC and stuff like that. It's kind of this idea that the business logic, sort of data models, the UI, and then the sort of way it talks to each other should all be separate. So the view is obviously the views. The view model is the messaging bit between the view and the models, and then obviously models as models. We don't have any models in this app just because it didn't need any. But in our view models, if we first of all, my microphone's moving, I think. There we go. So it just reads in the text. So when you click the button, it calls this text analysis. These are just a few properties. So it's all C# with getters and setters like you'd expect. Let's just get rid of them. Don't need them. Let's make this easy to read. So yeah, so you've got getters and setters. This does iNotify property change, so that when one property changes, you know about the other. So, and that takes a little bit of setting up, like you just need a base view model. And so I use a little library that a friend wrote that just saves you that time. So that's what that set property is referring to. But this is the good bit down here. So we're saying create a text analyzer and then send off the text that we read from that text box off to be analyzed. So if we then go into it, what it does is it spends a lot of guff setting up an HTML, like HTTP client and the different bits and bobs it needs to know, adding in our API key. Because when you go in the Azure portal, which is where you'll find Cognitive Services, when you set up your, whether it's custom vision or something else, it gives you an API key. And so you just have to pass that in as part of your request. So it builds the request up, and he obviously checks for success. Then starts handing the response. So all of this is just standard C# code. There's no fancy mobile stuff here. It's just C#. We're saying that, deserialize the object and then go through it and, based on the results, do some decision making. So as I mentioned before, it gives you a probability out of 1 score of the likelihood of certain emotions. So we're saying, based on the result, if it's less than 3, we're going to assume it's negative, which is what puts our sarcastic message in the red text. If it's normal, which is anything below 0.6 but above 0.3, then it's normal, and then anything else must be positive, so put it in green. There are a lot more emotions than that, but happy, sort of normal, happy and sad or angry are sort of the basics that I went with. And then that page we looked at before, which says, does a very simple switch statement based on the responses it got back. The more interesting bit that you didn't get to see, which is the actual body language stuff. So let's just quickly have a look at that. So we've got again, it uses view model. So this uses face client. So one of the things I didn't mention before, but it's quite cool, is that Cognitive Services supports both API REST calls with endpoints, which is what I did with the text analysis, just to show you that you could. So that text analysis stuff went on, the whole thing was fewer than 90 lines of code, but a lot of that was just setting up the HTTP client. So if you want to use an SDK instead, you can. As long as it's available, which I think pretty much most things will support an SDK, but if not, you've got HTTP to go back onto. But this uses the library that you can see here, Vision Face. And so it sets up the different bits that you need. So you've got a face client. Then some of this stuff is taking pictures. So a lot of the time when you're writing mobile apps, you know, some of the things that you'd want to be able to do, like taking photos or checking network connectivity, if you were actually writing those out of the box, the way that iOS would do it and the way that Android would do it, or even UWP, or it supports Tizen OS or Apple Watches, it supports more than just mobile. It can change, you know, how you do it is different, and that can sort of change how you do it. So what a lot of people have done, very clever, generous people, is created libraries that you only have to worry about in your shared project. So you make it available to all the platforms, but you don't need to worry about saying, hey, this is how you do this on iOS or Android or whichever platform. If the library supports a platform, then it will give you the ability to call it from your shared code and not to worry. So that's what I use here for the face stuff. So taking the picture to be analyzed, I use a media plugin called Plugin Media Abstractions. I think it's like XAMPP Media plugin or something on NuGet. But anyway, I use that to take the picture. So a lot of this code, again, is actually just setting up, taking the picture. It's not Cognitive Services itself, which is barely any lines of code at all. So we just set up some stuff around, you know, as long as you can take a picture, then take a picture. This image for analysis is that property of on the page, so that it's saying when you take the picture, redisplay it. Then, okay, say to the client, face operations, give it the attributes that you want. So face operations is kind of like the basic client, as it were, that you get in the SDK. Then we're just giving it some attributes. So when you call it, you have to say to it what attributes you care about. In our case, we care about all of them. So that's what this line is doing. Then we're just saying, go off and get the faces, and then move to the second page, because the result page is actually different. So if we look here, we've got our emotion analyzer. So that, ignore the comments about code. Has it commented out? I don't know why it's commented out. Let's go back to the interesting bits. Okay, so it's saying detect the faces. If you get any faces back, then navigate to the image result page. So if we then go to the view model for that, what that does is that takes the picture in so that we can display it again. And then for the emotions, it does a select. So it's saying for every face, get the emotions. And then further down, we have a dictionary. So it's just key value dictionary of the different attributes that you can get. So these are the options of emotions that Cognitive Services can detect. So anger, contempt, disgust, fear, happiness, neutral, sadness, and surprise. And then we're just doing it. So it's the name of the attribute and then the actual value of the probability of that one. And then based on what you get back, take the one with the highest score and send that back. So it's fairly straightforward. It just takes you onto that page, does the analysis, and then comes back with a result. Over pizza, we can play with this app so you can see what it actually looked like. Because sod's law, as soon as I get off stage, it's going to start working, showing my screen. So just very quickly, so we've seen that one. So I just quickly want to spend a couple of minutes talking about some much better, cool examples of Cognitive Services, because do you know what? I've been doing QA for the past 3 or 4 months. I don't even write code anymore, so people out there can do a far better job than I can. But there's just a couple of examples of the power of Cognitive Services that I wanted to share with you. So one of them is, start from the top, this mobile chest X-ray analysis. So these were some interns at Microsoft Garage, which is their R&D department, and they came up with this concept of a mobile chest X-ray on an iPad. So it would, the link to this website is in the link at the end, so don't worry about reading the content for now, but it brings up this app. So they put together an app using Cognitive Services and Xamarin on the iPad that they can take a picture of chest X-rays, and then they can do, Cognitive Services can do analysis on it, which gives you feedback on what it thinks the conditions are. And I think that's amazing, because if you think about things like developing world countries where there aren't necessarily chest X-ray, you know, is it cardiothoracic, I think they call themselves, experts, you may be able to look at this and say, this is what this is. So by having this app that can do some of the analysis, you're saving lives, because rather than saying to someone, you need to travel 100 miles to the big city to this hospital just to see a specialist to look at this, someone's actually able to take this app and use, machine learning and the sort of power of the work that Microsoft has done to just look at this and go, do you know what? I think this is the most likely thing. It's very likely, so they might actually go ahead and get some treatment for this from a normal doctor. So this opens up support from normal doctors who maybe aren't chest experts, but they can just use these tools to get some support so they can help more people. So I think that's pretty cool. And then another one I wanted to share is skin cancer prediction. So both my examples are medical, but I think this is where cognitive services in so many ways could have the most impact, is in medical things. So can we switch themes? There we go, switch to light theme. We're giving a talk now. Dark theme's not welcome. So this is a whole blog post where they talk about what they did from start to finish, but what you end up with is an app that they've put together. They even show you how they train the data. Is you just end up with an app that does skin cancer prediction. So it looks at pictures, I apologise for the quality of the image and the size, but it looks at pictures of skin lesions or moles or something on the skin, and based on millions of points of data that's been fed and trained on, it can make decisions on whether or not you need to be concerned about these sort of, lesions or moles. So, even if it's not a developing country, even if it was in this country, this impact is huge because doctors get tired. They're overstretched, underpaid, unappreciated. Hashtag no more politics. They get tired, and sitting through having to study these images all the time and having to work out what's important and what's not, they could make a mistake. Computers don't get tired. All right, they need a restart once in a while because Windows loads too many things, but they don't get tired in the same way. So by being able to use cognitive services to recognize these and go, do you know what, the chances are this is nothing, you could get through so many more images just by filtering them through this app rather than having to be a doctor that sits there for 10, 15 minutes really analyzing these x-rays. So, medicine's advancing, but cancer is still a killer. And so I just think this is cool because it's a great way to catch things early. And so I just wanted to share them with you because these are much cooler examples than anything I could put together. And I just think it's great, the power that these things give to you. So let's just go back to... Here we go. Let's play this. Oh, let me get rid of that. Go away box. There we go. So this is my beautiful The World is Your Oyster drawing. If you can't tell, because I can't draw, because, as well as being on the autistic spectrum, I'm dyspraxic, so when I was little, I crawled like a giraffe, one arm, one leg, rather than alternate, and silly things. So I can't draw, so that's the best World is Your Oyster drawing I could manage. But I thought it was appropriate because I think cognitive services opens up so many possibilities, whether it's around medical or, making the world more accessible to people with disabilities. There's lots of things that it can do. So, just quickly in summary, we've learnt what Xamarin is, how to get started, examples in 2 languages, and we discovered using cloud computing with cognitive services to do cool things. It would have been cooler if I could screen share, but do you know what? Tech demos. My last tech demo went a lot worse because I updated Visual Studio before I went live. Don't do that. But with that, woohoo, see, that's what you should see. That is my hotel room. It looks like I haven't made the bed, but it's just a pile of stuff. So thank you. I am very happy. And that link at the bottom will take you to a gist on GitHub, which has links to the slide, links to the examples I showed you, and also some useful resources like the documentation and a couple of textbooks that I really enjoy that I thought everyone would benefit from. And now, pizza and beer. Pizza? Pizza and beer? Or pizza? Pizza and beer.
We're going to switch around laptops, and then we got Isaac Abraham talking about SafeStack, functional web programming in F#. See you in 10 minutes.
There you go.
Thank you.
I better go and prove that this app works. Thank you. I normally cover.
Save me some time as well, so I don't have to explain what MDU is next.
Well, there you go. I try not to cover too much, but at the same time, I want to cover enough. Yeah, yeah. Just taking the stuff off, and then you can have the lapel mic back.
Yeah, exactly. Just found it. Hopefully it'll be all right.
Sure, I'll come back for them. We'll take stuff now. If I can eat pizza. Oh no, pizza. Sorry, I want pizza.
So it's 19:35 now. We'll start again 19:45.
Yeah.
45 minutes from you, half an hour from Fulia.
Yeah, that'll be fine.
Cool. Awesome. Amazeballs.
Yeah. I had to cut DevOps out of it because I was worried it would go on too long. I planned to cut DevOps out of it. I didn't just cut DevOps out of it tonight, but I just thought, you know what, it's interesting to know because people in an enterprise like to know about.
Yeah, it's number 2. Talking, 1, 2, 3, 4, 5, 6. Let's turn Fleming high. Just double checking your mic for you. 1, 2, blah, blah, blah. 1, 2. You've still got that? I've turned 1 off. I'm still wearing 2. 1, 2, 3, 4, 5, 6.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. but wait a minute, that's better. Right, let's start again. But no, seriously, thank you for all the organisers for making this happen. I know user groups and conferences require a lot of organisation, so I appreciate everything for making it going so smoothly. With that said, let's get started. Usually this takes about 90 minutes to 2 hours in a user group, so I'm trying to compress everything into 3/4 of an hour. So I will try and keep things succinct, and but not unreadable or ununderstandable. So yeah, let's get started. So just a little bit about me first. So that's me, Isaac Abraham. That's good. I've been using .NET since 1.0. So yeah, right at the start, before generics, C# for probably 15 years odd. Been using F# for a few years now. I obviously come from London. You can probably tell from my accent, but I live in Germany now, just north of Frankfurt. I'm the founder of CIT, so we're a consultancy. We do F# and Azure training, consultancy, coaching, things like that. Also do a lot of stuff on open source projects. So I work on Safe, of course I'll be talking about today, but various other packages and projects as well, like Packet, which is a NuGet sort of tooling library. Just quick show of hands so I know roughly who I'm talking to. How many of you here are actually using F# today? It's pretty much about what I expected, so that's good. So that means that there's plenty of you that are going to get something out of tonight. I assume, though, most of you have at least heard of this thing called F# that people use for, like, maths and data science. Yeah, I should hope so, yeah. Great, so with that said then, I'm just going to do a quick 2-3 minutes on F# as high-level thing, and then focus on SafeStack. So what is F# first? So it's a general-purpose programming language, and that's really the key takeaway I'd like you to have from today. It's not a specific language for a specific type of task. Basically, anything you can use that you can design or develop in Java or C# or Scala, you can pretty much also do in F#. The big difference is that unlike, say, C#, which is more of an OO language with some functional constructs built on top of it, F# is the other way around, really. It's more leads you towards a pattern of writing code in a functional style and allows you to do some object orientation if you need to. It's really good for domain modeling. It's got a nice type system, great for working with data, and it leads to what I call the pit of success. Has anyone heard of this term, pit of success, before? Okay, so some of you. What that really means is it makes it easy to do the right thing and hard to do the wrong thing. That's in a nutshell what it really means. Just some other sort of high-level things. So you get full access to the .NET framework, the .NET libraries, NuGet packages. You can call them all from F#. It runs on top of .NET. So you can work with classes and so on. You can use Visual Studio, Rider code, and it works with like normal NuGet. There's this library I mentioned already called Packet, but you can use NuGet as well. There's no reason why you can't. So with that out of the way, these are probably some of the key differences. And if there's one slide that you really take away from today about where the two languages, sort of C#, VB.NET, and F# differ, these are kind of the different sort of comparisons, I would say. The main sorts of things here are things, a good example is mutability. So in C#, if you want to make a read-only field, you have to put read-only everywhere and const everywhere, and it gets kind of painful if you're trying to make immutable objects. In F#, it's the other way around. By default, you don't have to put in any keywords. Everything is immutable. And if you want to work with mutable data, you start having to put in the word mutable everywhere. So it makes it harder to do mutable, but the benefit of that is if you want to work with immutable data, really, really easy. The same thing with things like statements and expressions. In F#, everything is an expression, literally. So there's no such notion as like a statement, really. Everything is an expression. So if you've been using C#8, anyone? Yeah? Anyone know like switch case expressions, this new thing? So that's like the default way of doing sort of pattern matching in F#. You don't really have the notion of like these stateful classes. You have data and you have behaviors. And the two are like kept distinct, which is, again, very different to how you tend to do object-oriented development. does some misconceptions. This whole thing about F# was originally about maths and science. I think that was kind of a useful tactic for Microsoft Research when F# was starting off to differentiate itself from F#, but it's not really true. It's just a general purpose language. F# is not hard, and I say this as someone who's been working in C# for like 15 years. When I started using F#, there was really little documentation. The tooling was much worse than it was today. But it is different to C#, and that's really, I think, the distinction. It's not difficult, in my opinion, but it is different. I often get asked, do you think is F# better than C#? The answer is it depends. It really depends on what style of software development and paradigms you like to do. So if you're taking things from the right-hand side here, you're trying to write code which has got pure functions, everything's expressions, probably F# will be a good fit for you. But if you like writing things in an imperative style with stateful classes, with statements, you'll probably find F# actually a little bit painful. So when I say then the answer is, there is no one size fits all. It's really just what you like. A quick primer. I'm really going to go through this very, very quickly, just in the interest of time. So F# has just the notion of values, and this is just so you can see a bit of the syntax, so that when I start jumping through the code, you're not completely shocked. So you've got this notion of type inference, just like in C#. So here you've got let instead of var. That also works for functions, though. So this is just a function called hello world, which takes in name, which is a string. You don't have to put in the types here. F# will basically figure this out based on usage. So it knows that name is a string. And indeed, down here, we can say, well, I'm calling hello world with the name Isaac, and then text is a string. That's what it returns. It's got tuples. I'm not going to bore you with the syntax. It's basically the same sort of thing like C# has. So you've got tuples in the language. It's also got records. This is probably worth looking at a little bit, just because this is coming to C#9, probably. So a record is just like a DTO in many languages, but it comes with a lot of nice features. So you get like structural equality out of the box. You don't have to do like the overrides of get hash code. Is anyone using ReSharper when you hit the control dot thing and it does the magic of generating all the comparisons? That's sort of what this does for you. Interestingly, down here, where I've said I want to create an instance of this record, you don't have to use the new keyword or say what type it is. The compiler indeed figures that out based on the usage. So it knows there's only one type which has these two fields, therefore this must be a person. I'm not going to bother with DUs. Discriminate unions, I will just mention briefly because I believe they're also coming to C#9 or some form of them. They're essentially like enums on steroids, or you can think of them as class hierarchies, like inheritance hierarchies that are closed at compile time, and they give you some nice features. So I won't talk too much about that. F#'s got this thing called a pipeline operator, which is like the only real operator that you don't have in C#, I think. And it just lets you do pipes of take some data, do an operation, do another operation. It's kind of like extension methods, except in F#, anything can be an extension method, really. You don't have to explicitly design it as such. Leave that. This is actually interesting. So when I used to talk about F#, this was one of the slides where I had to say you can't do null as a proper value. F# doesn't allow it. Nowadays in C#8, that's like, yes, that's what we're doing as well. So it's hopefully not that unusual to consider this idea that you can't have null. F# has different ways of working with that. The biggest difference I see for people learning F# from C# is it's white case sensitive. So you don't have curly braces, you don't need semicolons. It's basically make sure everything lines up, life is good. If things don't line up, life is bad. So that's it. Also, equals means equals in F#. That's the only bit of politics I'm going to do tonight. So what this means is if you say something like x equals 10, that's not an assignment. That's comparing x and 10. Okay, yeah, we spoke about that. Skip that out. Okay, so on to safe. So with that in said, what is safe then? So safe is a set of libraries for creating cloud-ready web apps that take advantage of type safety and functional first programming. Those are the real drivers, those two things, type safety and functional first. It's not a framework. It's not a monolith. Really, all safe is some tooling that we've built around existing libraries and some documentation, really. Why did we create safe, though? So there are a load of these cool different F# web apps sort of technologies and frameworks that were being built over the last few years. But there was no coherent story. They all sort of fit a different part of the web development project, whether it's client-side or server-side. But there was no documentation. It was kind of difficult to get up and running. No one was offering support of them. And we heard from a lot of people saying, we'd like to try these tech, but it's just too hard to get started. So what we wanted to do was lower the barrier to entry of both F# and web dev. So we wanted to attract people to look at F# if you're coming from a web development background maybe, or .NET, or maybe JavaScript. And we also wanted to make web development easy for existing back-end F# developers. We wanted to increase trust in these F# web tech. Again, because they were mostly open source, written by a couple of people, there wasn't so much of a good documentation story around them. And this last bit here, this allow reuse of existing tech, was important. We didn't want people to have to throw away everything they already knew. So if you're using Safe, you don't have to throw away, for example, ASP.NET Core, or you don't have to throw away uses of JavaScript libraries. We wanted to allow you to continue to use them, but just write things in F#. I'm not going to talk about all of these today, but basically it was around feeling that you could do functional programming across the whole stack, rather than feeling that you've got to push to fit the language to meet the framework. So if you're using something like ASP.NET MVC, it's an OO framework. If you're trying to do it in F#, it feels a little bit unnatural. And we wanted it to feel completely natural to use F# to really take advantage of the language. And this last one here I'm going to talk about was to remove what we call the impedance mismatch between client and server. Oftentimes, who here is doing like TypeScript or JavaScript on the front end in their web apps today? So great language, TypeScript. It's obviously different though to C# if you're doing C# on the back end. So you're sort of writing one language on the back end, you go to the front end and maybe using TypeScript or maybe JavaScript. Type systems out the window, it's completely different. We wanted that to be seamless, that you could write on the browser and on the back end without really thinking about it too much. So one of the real benefits, I think, is that you can write apps entirely in F#. You don't have to write any JavaScript if you don't want to. You don't have to do C# or VB.NET. You can do end-to-end F#. You don't need to know JavaScript. It's obviously a benefit because F# runs on top in the browser on top of JavaScript. But you get all the benefits of F#. So you get strong typing, the usual sort of features in the language. And on the server, runs on .NET Core, runs on ASP.NET Core actually. So there's nothing that you have to give up in that regard. And there's a very sort of what I call a rapid development cycle. And we already actually saw this in the previous talk where we saw this notion of like hot module reloading or hot restart, I think it's called. You'll see this in a minute as well with F#. So very briefly, the different components of SafeStack is called Saturn, which is the S, which is basically the server-side component of Safe. Azure, that could also be AWS, still works with the Paradigm, which is basically a hosting platform. Fable, which is the client-side component that lets you write F# in the browser. And then this last one is Elmish, which we've actually already heard of tonight, which is great, saves me a bit of time, which is the paradigm for writing front-end web apps in a functional style. And what I'm going to do for the next 30 minutes or so is basically look at these three components. We're not going to look at Azure today, and I'll just show you a couple of quick demos of each of them. I'll skip out some of these slides. Okay. So what I'm just going to do to start with, though, is rather than start at the bottom, I'm going to show you an end story. That way, if I run out of time, you've still seen something useful before the end. So this is a Safe app, which called Safe Search. And the idea here is anyone who lives in the UK knows that we are all obsessed by property prices. That's what everything is all about these days. So what this does is it downloads the UK government published house prices, which is published every month as a CSV, I think, parses it, uploads it into Azure Blob Storage, puts it on top of Azure Search so we can do some searching and then lets you find them. So I'm just going to do a few things here. So I'll start typing. And you can see already we've got some client-side interactivity. So we get suggestions there. If I go to empty, then the search button gets disabled, things like that. These are like fundamental, obvious things that you would expect from any sort of web app. But when I started using Safe, I was like, amazing, I can write sort of client-side stuff in F#. And we get some results back, searched from Azure Search. You get things like faceting, so it sort of groups up the results. Very nice. I can click on a button here, and I can get a pop-up with some more details. I even get Google Maps integration, things like that. I can also do things like locality search. So this is now using Azure Search to do things like long latitude search. So it's showing properties that are sorted based on their location and the distance from the top result. And then I can look at the map and I can actually do some programmatic access to it here. So you can see these little dots are based on the results. And the real idea, what I wanted to show you with this one is that this is Google Maps, this is a React component, but I'm actually using F# to programmatically work with this. So I don't have to throw away all the existing sort of JavaScript technologies and libraries. This is built on top of things like Bulma, which is a CSS library framework, React, JavaScript, all those sorts of things, and of course hosted in Azure, running on ASP.NET Core. Good. Skip those out. Interesting thing here, that is 93% F#. The only bits of JavaScript is a Webpack file. Who here's worked with Webpack before? You know what I mean when I say it's not the most fun thing to work with sometimes, but that's the only file that we've had to sort of put in here. There's one HTML file, which is just a shell and a tiny, tiny bit of CSS. Everything else in there is F#. There's no HTML for the actual views, all in F#. So what I'm going to do now is just talk about the first of those sort of pillars, which is Saturn, and we'll see how those sorts of apps I just showed you can be built up. So Saturn is an F# library for writing F# server-side web apps. It runs on top of ASP.NET Core, and this is really important because it means that you're not leaving the typical Microsoft.NET ecosystem. You're still running on top of that. You've got all the sort of excellent performance enhancements every time there's a new version. Saturn just gets that for free. It just gives you a set of helper functions and methods that live on top of ASP.NET Core that let us write endpoints in a nice F# style. But it's not an abstraction layer. It doesn't hide ASP.NET. That's really important, so you can always drop down to that as well. Right, so here's the first coding demo. Hopefully it will work. So first question, is that big enough at the back? Can you read that so far yet? Okay, thumbs up, good. So what I'm going to do is just create a Saturn app from scratch. Hopefully it will work. So what I'm going to do to start with is create a .NET console application. I'm just going to use standard .NET tooling. There's going to be no sort of crazy F# stuff here. So the only thing I've had to put in is this extra --lang F#. And then after .NET thinks about it, I've now got an F# application. I'll just show you what it looks like. So it's just the hello world, and I'm going to start running it now. But before I do that, I should probably add Saturn as a dependency. So just to show that this can be done with normal NuGet, I'm not even going to use Packet or anything like that. I'm just going to copy and paste a load of package references. So let's go to our project. Right. Yes. And I'm going to click .NET Watch Run, which basically means every time I change the file, the application's going to restart. So I can quickly test this out. So let's start by writing our app. So I'm going to open a couple of namespaces. That's like the equivalent of using, nothing more there. And I'm going to create an ASP.NET app. Let's do that. Application. I don't want any router. Run app. That's it. That's now an ASP.NET app with a full pipeline plugged in. And you can indeed see down at the bottom, once .NET starts, we've now got our content route, ASP.NET. So that's basically a wrapper around all of the normal stuff you do with the service config and all of that stuff. But obviously that's not really doing much, so let's add some routes in where we can consume these endpoints. So I'm going to create a router. Let's say get API foo. And I want to return back the text, hello London, if I could spell. And now I want to use that router. And now I'm going to save. It's going to restart. And now comes the moment of truth. And to save time, I'm using a code extension, which lets me hit endpoints directly from within it. Huzzah. Right? That's what I'm talking about. Let's do a bit more though with this. We'll play around for a couple more minutes and then we'll move on. So I'm going to just do some parameterization. No, we'll show you how to be hipster. If I don't want to do it as text, I want to do it as XML. Why? Come on. That's what it's all about. So now if I can do send request, and now, boom, we've now got it as XML. Question, was that? Oh, yes, the font. Yeah, of course. Great, good. So now we've got some XML there. What is really happening here is this is really like an ASP.NET Core filter. It's saying if I get a request that is a GET and the path matches this, then do whatever this XML function does, which basically modifies the response, modifies the response headers, and so on and so forth. Let's do something a bit more fun, and I will do some JSON. This is really proper now. So let's create a type, a record in F#, which is going to have name and age, and let's put an ID field in as well. And let's make a function, create person, which takes in the ID, and it's going to return back name is Isaac, age equals 40, and ID equals ID. Believe it or not, I am white male 40. Exactly, that's what it's all about. So let's do a bar, and right, let's create what we're going to create a let's create a parameterized route. So I'm going to say create person, and I'm going to return this as JSON. What's going on here? So we're creating a route that is parameterized. %i means integer. So it's going to take in a number as the third argument, and it's going to chuck that into this create person function, which takes in an integer. We're going to set that as the ID, and then I'm going to return the result as JSON. So this piping is kind of similar to what you sometimes see in Bash and batch files where you're piping one thing to another. So let's try this one. And there we go. So we've got some JSON now. So I've got name, age, and ID. Very nice. And indeed in F# we could even get rid of this if I wanted to, because we've now got this thing called anonymous records. Where I just put these vertical bars and it creates a type on the fly. It's kind of like anonymous types from C#. But what this really means is it's really quick and easy to create some data that you want to expose as JSON. The last thing I want to show here is just going to be about how we can compose routes together, which is a really important part. But before I do that, I want to show one last part of Saturn, which goes back to what I said before about running on top of ASP.NET. Let's assume we needed to do something a bit more low level, or we needed to get to the real ASP.NET Core pipeline. Well, that's actually not too hard. We just pass in these sort of hidden parameters that we never saw before. Let's say you want to return this as JSON. Good. Right. I'm just going to put a type annotation here so that I can get some IntelliSense. So this is a Microsoft ASP.NET HTTP context. And if I look at that context, you'll see this is indeed the standard ASP.NET Core pipeline. So you can get right to the bottom. If I want to change the response, for example, and change the, let's say the status code, and I'll make it 202. And then I save that. That's all I need to do. So I can always drop down to the bottom level if I really need to hit the low level of ASP.NET. But only if I need to. If I don't, then all is good. And you can indeed see up here, code is 202. Good. Right. Let's open up the demo file so I can save a minute or two of time. And you don't have to watch me fumble around with the keyboard. What I'm going to do is create a second set of routes now. And this is actually really important. The idea that you might have different parts of your app where you've got different routes and maybe different patterns or behaviors. Maybe some routes are secured. You only want admins to get in and some are not. How can we sort of plug them together? So here I've got two different sets of routes, and I can use this nice forward keyword. So I can say forward anyone that goes to API orders, push to order routes. So now we're basically plugging together different parts of code, building up bigger and more complex routes. So you can imagine you start with lots of small ones, and at the end you've got one big router that's distributing everything. And obviously all of these can have different security settings, different pipelines, different plugs, and so on. Okay, good. So that's the end of sort of the back-end side of things. What I want to talk now about is Fable, and this is probably the bit that's a bit more foreign, which is this idea of F# in the browser. How and why would you do that? So what is Fable? So Fable is a tool chain to bridge the gap between F# and JavaScript ecosystems. You get standard JavaScript emitted from F# because Fable actually runs on top of Babel, which is this tool that can emit JavaScript. All Fable does is take F#, pushes it into Babel, and then Babel does the rest. You get access to all the standard JavaScript things like standard types, the DOM, all of those libraries, and it indeed lives on top of JavaScript. Fable is not a .NET tool, it's actually an NPM package. So it doesn't hide JavaScript, it actually says, let's embrace JavaScript, let's just let F# play alongside it. So in that regard, it's a bit different to, say, Blazor, which is more about .NET on the browser as kind of an isolated island. You can take both sides, so you've got F# types, functions, things like this. You can even do some BCL, like system libraries, in the browser. I'll show you that in a minute. But we also get access to things like TypeScript libraries. You can sort of code gen F# libraries from TypeScript typed files, or you can handwrite your own sort of interop layers as well. Why would you do F# in the browser? So for me as a long-time .NET developer, I found JavaScript, and this was even in my C# days, I found JavaScript really difficult because it's dynamically typed. Didn't really fit with the paradigm I was used to. With F# on the back end, it opens up a lot of options. I get a nice static type system, I get type inference, nice powerful compiler, and importantly, I can run on both sides of the wire. I can run F# on the server and on the client, which is good. Also, one of the nice things you get with Fable is that it integrates with the whole JavaScript ecosystem. So I know this is a bit small, but basically what it's saying is we use things like Webpack. So you can get things like hot module reloading, a dev server, source maps, bundling, minification, all these things that you've come to expect from JavaScript anyway, you don't lose them with Fable. You actually get to keep using them, which is great. So let's have a look at a quick demo of Fable. So what I'm going to do is start this web app up, and you'll notice when I do this, I'm using Yarn. So Yarn is a JavaScript tool, nothing to do with .NET. But that's actually how we're running our Fable app here. So it's going to kick in, you can see in our Fable compiler, it's going to compile some code, and then we're going to end up with a browser. And at this point, I'm actually going to switch to a side-by-side view. So let's move that there, and move this guy here. Right, there's our app. Fantastic. Nothing to see. So what do we actually have behind the scenes? And in fact, good, right. Let's go back to the browser and just show you what we have here. So we have a simple HTML file. Nothing too imaginative here. It's got a title, a couple of things on the top, and then an H1 tag, which I've given this great name called thingy. Now what I want to do is get a handle to this element and start working with it in F#. So this is like pretty low level code. So let's say let e equals browser .dom .document. Now I get handle to all these nice little things. So this is like the JavaScript DOM, but with type system in F#. So I can say get element by ID thingy. And now let's say inner text goes to hello London. Let's just see this. Hit save. Boom. Okay. Obviously, this is pretty crude as an example, but just so you can see we can do proper things with it. Let's say greet. So I'm going to create a function, city, hello, city. So we can do entire functions in here, greet London. Same thing. But this is not like just some small subset. This is the full F# language in the browser. Let's go one step. Let's level up and really take it up a notch now. I'm going to go to a button instead. And I'm going to say inner text equals click me. So I've got a button there. Great. Let's put a click handler on. OnClick is a function that takes in an event handler. I'm going to do browser.dom.window.alert. Hello, London. Right? So this is just normal. This is like normal F# syntax here. This fun E stuff. This is like the equivalent of a lambda expression that you've probably seen a million times in C#. We can also, interestingly, do stuff like this. System.datetime.utcnow. How's that working? System is a .NET thing we're running in the browser. What Fable is doing is redirecting the call to datetime to the equivalent JavaScript function behind the scenes. So you can basically look at the BCL and call certain functions, and they will actually run on the client, being transparently mapped to the equivalent library.
What do you get if you call a function for which no mapping is?
Yeah, then it won't compile.
Okay.
So you basically have you can create your own ones, but out of the box it will just say, I don't know how to map this.
Okay, all right.
Yeah, you won't get runtime error.
And it'll fail compile time.
Yeah, exactly. Yeah. Okay, good. So the point I'm really showing you here, though, is I'm writing F# in the browser. There's nothing really too spectacular there, but it's more the idea behind it. And I want you to keep in mind what I showed you at the start, where I had the app with the safe search sort of thing. That's basically using the same principle as this. But obviously, no one is going to write an app these days going straight to the DOM, because we've got all these great libraries like Angular and so on and so forth, right? So this is where Elmish comes in, that Luce touched on earlier. So if we look at these libraries, I mean, we saw MVVM before, right? We heard what that is, and probably you've heard of MVC if you've done anything with Angular. The problem with all of these from an F# perspective is they all work with this idea of I've got some state and I'm going to mutate it and maybe send some reactive events. They don't really fit naturally with F#. So what we have in F# and with this Elmish model is this idea we have an immutable data model at the top. We never change it. We send new versions of this model, and at the bottom, we're going to have a mutable UI that we never see. And there's some magic in the middle, there's this abstraction layer that's going to take care of it for us. And that's what this MVU pattern does. And I'll just take a minute or two to explain it and then move on. So what we have is three components. You've got the model. Imagine something like an e-commerce site. The model might be something like the basket. Yeah? And we have an update function that says, give me a model and a particular command or an action that you want to do, and I'll give you a new version of the model. So it might be given an empty cart and add this item to the cart, give me back a new version of this model, which would be a model with one item in it, a cart with one item in it. And then we give this model to the view, and the view basically renders it out. Now this is where kind of the magic happens here. What happens here is rather than sending through and refreshing the page every time, we're actually sitting on top of React, which is this library that Facebook have written. And that does this really smart thing where it says, what's currently being shown on the HTML in the browser? What have you given me? I'm going to do this diffing engine and only make updates to the bit that have changed. So you don't need to refresh the page every time. It just makes these small updates every time. So it's nice and quick. So I'm just going to give you a very quick demo of this Elm architecture. So I'm going to kill all of that. Boom, boom, boom. And ironically, this is the same counterexample that we saw before, because that's the only one that F# developers know how to do. Yeah, it's even worse for me. I'm supposed to be an F# developer. So what do we have here? We've got an up, a plus and a minus button. There's no styling on here, but who cares? So we hit this button, and it goes up by 10, and we hit minus, and it goes down by 1. Fantastic. So what's really happening here? Well, I've got my model, and that's basically saying, what am I trying to model? What's the state in this app? Well, it's a number, so it's an int. And we've got two commands, increment and decrement, which relate to what we can do. We start with an existing model of 0, and then we've got this update function that says, given this message, which might be increment or decrement, and a model, what are you going to do to it? So let's say I wanted to change this actually to say -10. Then I can update this, and we can start again. Fine. That's all it's doing. And this is the bit that usually catches most developers out when they first see this. It's like, whoa, what's all this? So this is an F# DSL. It sits on top of React. You can see there, assembly Fable React. So this is giving a div, a React div out, which has some props. And in F#, a list is just open and close square brackets. You don't have to do system generics, list or whatever, open and close square. So it's got some props, like attributes, and then some children, which are these 3 guys inside it. So we have a div with 3 children. One is a button. On the click of the button, I want to send an increment message to my update function. I've got the value that I'm going to show, and I'm going to have a decrement button as well. Not too much. What I would like to do, though, is just show you the developer pattern when I make some changes to this now. So what I'm going to do is add a new command into the system. So I'm going to add a new command called reset, which should reset the counter to 0. Simple. Let's change that. So the first thing here is, you probably can't see that at the back, but I've got this orange squiggly underneath the word message. And this is the compiler telling me, you've added a new command, and you're not handling it in your update function. Please handle every case in the system. So in this case, it's saying, look, the value reset may indicate a case not covered by the pattern. You haven't told me what to do when I hit a reset command. So let's fix that error. And I'll say 0. So when we hit reset, the model is going to be set to 0. We just start again. And then in the view, that's not too hard either. It's going to copy and paste my button, dispatch the reset message, and the text will be reset. There's our new button. Click, reset. Easy. So this is the sort of pattern that I'm talking about when I say we're using this Elmish pattern. It's basically just code. There's no overhead or having to change from one language to another. Everything is just in F#. A lot of things become a lot simpler when you start looking with a code-first approach to a language as well. You don't need things like converters to change a Boolean to a visible. It's just basic programming, yeah? If-thens and things like that. So you gain quite a lot, actually, with that. Okay. Good. Right. Since we're OK for time, we've got 5 minutes left, Dylan? Yep, great. So you've seen these kind of 3 different components. Saturn on the back end, this Fable, and this Elmish, but they're still like disparate components, so we came up with this idea of the safe template. It's just a .NET template, same sort of thing that you've seen before, and all that does is give you a ready-to-go application with all the different components hooked together, the Webpack set up, the dependency set up, and you can basically just start from there. It's also got loads of like tweaks, so you can do things like set it up with Azure deployment to the app service with ARM templates. You can use Docker. All of those things are sort of ready to go if you want to try it out. So all I'm going to do is just show you this template very, very quickly and just show you what the out-of-the-box experience looks like. So let's stop that guy. Safe. So before I actually kick the app off, to save time, I've already created the template, but just so you can see what it looks like. To literally create, once you've downloaded the template, you just say .NET New Safe, and you'll get everything here. What is it actually giving us? So it gives us a client, which is basically this Fable and Elmish stuff. It gives us a server, and it also gives us a shared file, where you can put types in that you want to use on both the client and on the server. So you don't have to worry about this thing of, oh, I've got a C# object on one side and a TypeScript object on the other, I've got to convert them. That basically will just happen for free for you because it's the same language on both sides. Now, if I want to start this app, one of the nice things we added is this thing which we call full stack debugging. So I can just hit F5 in code. I should point out at this point that all of the safe stack stuff you can do in Visual Studio or Rider as well. The only thing you couldn't do is this full stack debugging because code basically has this ability to hook into Chrome to do the debugging which Visual Studio can't do. So it's now started up the server. and it's now building the client as well. Hopefully this won't take too long since we loaded all the NPM dependencies about an hour ago, and it finished about 59 minutes ago. While it's doing that, I'll also just point out that this shared thing doesn't have to only be types. You could write functions. Customer validation on both sides of the wire. Well, just write it once in F#. It will get transpiled into JavaScript on the client, run as F# on the server, no problem. Right, we're on. So the app's launched up. Like every F# app, like I told you, it's a counter, the same thing as before, except this time we've got green buttons. Super important. But it's the same thing, so I can hit up and down. But what's nice is we can do a few things that we get as a result of sitting on top of JavaScript. So if I go to the server, this is a route that gets called when you start the app up to get the default value. I'm going to put a breakpoint there. And I'm also going to go to the client. And let's have a look at our update function. Here we go. So we've got our different commands here, like we saw before, increment and decrement. And I'm going to put a breakpoint just on a couple of these. There we go. So I put a breakpoint on the client, and I put a breakpoint on the server. Now I'm going to hit F5 on this guy. So, server breakpoint's been hit. And I can mouse over this guy, and it's just normal.NET. So hopefully, he will give me, there we go. So you get the value, and I can look and do the call stack, and so on and so forth. Nice. Resume. Now hitting a breakpoint on the client. So this is JavaScript that's being pushed through source maps into F#, and then pushed back into VS Code. Yeah, and I can indeed do highlights, and I get the value as well there. So this is pretty seamless. You know, obviously it's JavaScript underneath the bonnet, so you're basically playing on quicksand at the end of the day, like that. But you can get these nice things that really wouldn't be possible in many other languages. And it's all sitting on top of VS Code. You know, that's nothing F# specific. If we're really honest about it, F# is a tiny community in comparison to C#, and there's much fewer developers. The only way that you can make something like SafeStack work is by standing on the shoulders of all these other giants that are writing these great tools. So we're using like React, Babel, Webpack, VS Code. By doing that and playing with them nicely, then you get all these nice things almost for free. Almost. Another thing we can get is Redux. Does anyone know what Redux is? Hang on. Right, let's carry on. Yeah, so because we're using React and Redux on the top, what I can do here is click this button, which does magic. And then let's go to the bottom here. Great, OK, and I can close that one down. Right, now I hit the button a few times, and I'm going to keep doing that now. And we get the state history now, which we get for free. This is nothing that any F# developer has written. This is coming from the Redux language, so I can framework. So we can now go back in time and see exactly what the application was doing given the state of that model. And because this is a purely functional system, it's fine to go back in time because there's no mutable state. It's just what was the state of the model beforehand. So I can go back and forwards. I can see what changed. It was 41, then it went to 42. Yeah. You can even download this state from Redux, email it to someone else, and they can reload it into their browser, and it will just carry on. So, yeah, nice. OK, good. Just wondering if there's anything more I really wanted to show. OK, the only other thing I'll show you is the hot module reloading. So you've kind of seen that already. The only real difference here is this. Now, if I start making changes here, if you remember, we started with the state of 42, and it's now 34. If I go down here and change some of this text, so let's say, let's find the press buttons. Press the buttons, hit save. Not only does it change the text, it retains the state. So you can basically load an app, load some data into it, and start playing with the UI. Just make some changes, see how it looks. You don't have to restart every time. This, for me, was like a game changer from an F# perspective, that I can just quickly start opening it and use it as a scratch pad with a live application. OK, good. We're almost out of time, so I'm going to draw it to a close, but there are loads of libraries out there that are things that sort of make this even nicer than what I've shown you today. That's like the basic experience with Safe. So there's a library called Fable Remoting. Who here ever used Silverlight? Does anyone remember this thing called RIA services? Yeah, it was this thing where you could basically create an interface between the client and the server, and it did all the WCF crazy behind-the-scenes stuff. So this is basically an equivalent where you can create an interface, and it will do the HTTP calls, gets and posts behind the scenes. But as far as you're concerned, it's just calling an F# interface, nothing more than that. There are some reactive libraries with WebSockets like Elmish Bridge and Reaction. There's even a tool that will convert HTML to the Elmish F# dialect. So you can just take an HTML page and it will convert it to F#. We've already touched on Xamarin with Fabulous. There's an equivalent for WPF as well. So you can write WPF apps using this library and this paradigm. There's an official doc site, so I'll just show you that very quickly. Oh no, I've broken it now. Let's just stop that. By moving to that tab, I've now closed down my presentation. That's what you get when you run your presentation as an app. So there's a Safe doc site, so SafeStack GitHub, which has all the sorts of things that you'll need. It's got an overview, some diagrams that I put together. You can look at the different parts of the template, how to run it, what features. There's some examples there, starter kits, and so on and so forth. Let's go back again. Has it started up? Yes. There we go. Right, let's jump forward again. Good, back. That was shouldn't have gone so quickly. So there's some samples there on our GitHub repo, SafeStack. There's a dojo, which if you're going to NDC on Friday, I'll be doing a 2-hour session in the afternoon where we're basically going to build a Safe app from scratch. Well, not exactly from scratch, but it's basically 2 hours. You'll learn about F#, you'll learn about SafeStack, you'll get some hands-on experience. I'm not sure if I'm okay to do this, but we also do training on SafeStack and F#, so if you're interested, come find me afterwards. Now you can give me thank you and applause.
Thank you, Isaac. Okay, is Ilya here? Come on up, you're next. I'm afraid because of the 3 speakers and the tight schedule tonight, we won't have time for questions, but we're all, if anyone is at NDC, all of us are going to be around for the next 3 days. Come say hello, chat about it. And if not, we invented this thing called the internet, so you can talk to people who aren't in the same room. I've heard it's quite good. I've not really tried it yet. But yes, our final speaker tonight, and I'm going to introduce her very slowly, so we've got time to get everything. All right. So I don't know how many of you have been sort of keeping up with the whole what's going on with .NET Core. And, you know, .NET Core 1 was this wonderful kind of experiment. Let's build a tiny little runtime that's easy to port to different platforms. And then the community will build all the libraries we need on top of it. And the community went, we're not using this. It doesn't have any libraries. And so, sort of .NET Core 2 and 2.1, 2.2, there was a sort of awareness that actually we needed a much richer ecosystem to attract people to start using that stack. And what's happened with .NET Core 3 is a lot of the libraries that we know and love, like Windows Forms and WPF and WCF, are now going to be supported not cross-platform, but if you're running .NET Core on Windows, you will have access to .NET Core versions of all of these libraries for doing things like Windows desktop development. There's always been this challenge. Everyone's like, yeah, we're going to build Hello World in 10 minutes. But if your company has got code that's been running in production for 15 years, Hello World in 10 minutes doesn't really get you anywhere. You want to be able to actually start porting production code and running code bases. And so there's an awful lot of work in .NET Core 3 that has gone into bringing a lot of these, older libraries where there's a lot of enterprise code out there running so that we can start porting and running, desktop and the more, I don't like the word enterprise, but it fits in this context, more enterprise-style applications on .NET Core as a platform, which I believe is one of the things that Ilya is going to be chatting to us about. And that looks promising, because that's a PowerPoint deck, and I've almost run out of improvisation. A joke. What's happening on Friday? Oh, Friday. Oh, Friday. So if you're in town on Friday evening and you're not already coming, there is an event called PubConf. NDC are basically just warming up for us for the next 3 days. PubConf is going to be at the Barley Mow Pub around the corner in Westminster. It is 12 speakers, 5 minutes each. They get 20 slides, 15 seconds. I control the laptop, so they cannot overrun. They cannot go slowly. They have 5 minutes to get up there, teach you something, make you laugh, and then get off. Tickets are on sale now at pubconf.io. It is an absolute blast. If watching developers do manic fast-track sessions in a pub is your idea of a fun night out, which I realize it's not for everybody, but if it is, this is about as good as it gets. So it would be awesome if any of you haven't got tickets for that yet, come along. The really fun part is the 3 winners then have to do a 5-minute presentation to a slide deck they have never seen before. Oh, and I get to make up those slide decks this week. So if anybody does anything silly and it goes on the internet, it's going in one of the finalist decks. You almost ready? So, please, mic'd up, ready to go?
Test. Oh,
Brilliant.
Perfect.
Please give a big hand our third speaker of the evening, Olia Gavrish.
Hi, guys. Thank you. Thank you, Dylan. You did an amazing job. I feel like you delivered my talk already. My name is Olia Gavrish, and I work at Microsoft on .NET team. I'm a program manager, and right now I'm working on Windows Desktop. And that's what we're going to talk about today. Could you raise hands, guys? How many of you are working on Windows Desktop? Oh, perfect. OK, that's great. That's my audience. How many do WPF? OK, what about WinForms? UWP? Anything else? You can yell out. Yeah? What do you do? C#. C#. OK, perfect. So in the past, in the last 2 decades, Microsoft produced a few products for Windows Desktop. And some of them were quite successful and got a lot of users. According to Telerik survey, WinForms and WPF are almost 50% of people are choosing those technologies for their desktop development. And our Visual Studio statistics shows that we have over 2.4 million developers writing desktop applications in Visual Studio. And our telemetry shows that we actually have more WinForms users than WPF. And a few things happened in 2019. So before, WinForms and WPF were .NET Framework only. And last year, we announced that .NET Framework 4.8 is going to be the last version of the framework. And we did it because it was very hard for us to innovate in .NET Framework area without introducing breaking changes. And surprisingly, you guys don't like when we break your applications on production. So .NET Core is a new platform that allows multiple versions of .NET Core on the same machine. That way you can innovate at your pace, we can innovate at our pace, and no breakage. That's why we decided that all new development is going to happen in .NET Core. And .NET Framework, we will leave where it is. We're not going to kill it. It's going to still be supported. It will receive all security and Windows updates. But all new features will go to .NET Core. And with that in mind, and remembering about those 2.4 million developers, we realized that we need to provide a path to the future for our desktop developers. And that's why we made WinForms and WPF available on .NET Core. And we also open source them. So both of those technologies are in public repo. You can not only see the code, you can also report issues and fix those issues and actually collaborate. So now it's a product of the community. You can participate in developing those platforms. And .NET Core, of course, has many great features and differentiators compared to .NET Framework. How many of you have used .NET Core already? Okay, then I probably can skip this slide. You all know that .NET Core is great. And another thing that happened last year, we also announced .NET 5. Have you heard of .NET 5? Okay, great. So starting from November 2020, we will release .NET 5, which will be the unification of all .NET platforms, .NET Framework and .NET Core, and then we're switching to scheduled releases where every year in November we will give you a new version of .NET 5, 6, 7, and so on, and every other version will be long-term support version, LTS. So with that, big news with .NET Core 3 supporting WinForms and WPF, with .NET 5 as a future of .NET Framework, we got many questions. Of course, for your new desktop applications, we recommend to use .NET Core or .NET 5. What to do with applications that are already written in .NET Framework? So the most popular questions I received was, can I port my application to .NET Core? And do I have to port my application? Should I port to .NET Core or should I wait till .NET 5? And how much work will it be to port my app? So I will address those questions one at a time. Can I port my app? Yes. Do you have to? No, you don't have to. Port only if you see value for your application in .NET Core. And of course, if you want to be on the evolving framework, if you want to receive new language features, if you care about performance that .NET Core has to offer, if you want deployment flexibility, then of course, consider porting to Core. If you have application that is already in maintenance phase, like all development is done, it's just running in production, and you don't want to touch that code, it's totally fine to leave it on .NET Framework. We leave our applications on .NET Framework as well. For example, you probably have heard of Visual Studio. That one stays on Framework for now. Should I port to .NET Core or should I wait till .NET 5? I'll tell you a secret that behind the scenes, .NET 5 is basically next version of .NET Core. So you can think of .NET 5 as .NET Core 4. The reason for that is that for .NET Core 3, we already brought everything that we thought should keep living in .NET Core ecosystem. We added a lot of workloads such as desktop, AI, IoT, lots of APIs, and everything that we have not ported to .NET Core, it's either obsolete APIs or APIs that we cannot move to Core and we cannot evolve them in the paradigm of .NET Core principles. So we are creating new alternatives for them. And with .NET 5, it's very heavily based on .NET Core 3 plus new features. So it will be very compatible .NET 5 to .NET Core. And you can think of .NET 5 upgrading from .NET Core to .NET 5, same as you were to upgrade from .NET Core 3 to .NET Core 4. By the way, do you know why we called it .NET 5? Do you want me to talk to that, or you've heard that story? Okay. So, to avoid confusion, we decided that that is the future where we want all developers to go, and that's why we call it just .NET, not Framework, not Core, just .NET. And we picked a number 5 that would be larger than any version of .NET Platform that already exists. So .NET Framework 4.8 and .NET Core 3, 5. And usually when I explain that at conference, people tell me you should have called it .NET 42. And I heard it so many times that now I really think we've made a mistake. So how much work will it be to port my application from .NET Framework to .NET Core? Or in other words, should I know something before I start porting? Like, can anything go wrong? Yeah. Let's think about it together. We're taking an application that is targeting .NET Framework with .NET Framework API set. We're moving it to .NET Core. It can happen that we're using something that is not supported in Core, right? And for WPF and WinForms, we ported basically everything. But your application can have dependencies on, for example, ClickOnce that is not available in Core, or WCF server, or something else. If that happens, then once you port, you will get a nice little explosion. So to prevent that from happening, we have a tool. The tool is called Portability Analyzer, and it will tell you how compatible your app is with .NET Core. Or this is a desktop version. We also have a plugin for Visual Studio that will basically compare any application to any framework. It's very customizable. You can pick like Silverlight application, how compatible it to Mono or some crazy things. It's available on this link. Have you used it? Could you raise a hand if anyone tried this tool? Right, so I will probably show a demo for that. I will go to my computer. And this is, sorry. This is how the Portability Analyzer looks like. UI design is my weakest area, so it looks like that, but it works. And you simply provide the path to your project or your working folder. You click Analyze. And let me, while it's running, by the way, it's really fast, it's already done, but let me first show you the application that I'm running it for. I have this photo store demo. It's a sample WPF application that you can find on our samples repository. So it's just a tutorial application where we can work with pictures. We can order a print. I can print a t-shirt with this beautiful flower. That is the application. If we look at properties, here you can see it's using .NET Framework 4. You can see it right, yes? Okay, 4.7.2. And I want to see how compatible this app is to .NET Core. So I ran this Portability Analyzer. I click Open Report. What Analyzer does, it looks at your assemblies, and it compares the APIs of .NET that you're using to the set of .NET Core APIs. And if you have something that is not supported in Core, it will prompt you. So here, in the third column, you can see how compatible your assembly is with .NET Core. And 100% highlighted in green is compatible, 100%. Anything that's less than 100%, it means there are some APIs that are not supported in Core. But to find out which APIs these are, you can go to Details tab, and here you have all the information: target type, target member, assembly, and so on. But before jumping into refactoring or in despair, I encourage you to look at the first column where it says header for assembly name entries. And here, if you take a look for those yellow lines, it's Newton Soft JSON. So it's actually my NuGet package that I'm using. It's not my API. In that case, I don't need to do any refactoring. I just need to make sure that the library author supports .NET Core or .NET Standard. And I can go to NuGet.org and just see available supported versions. In my case, I know that Newton Soft JSON is supported on .NET Core, so I don't have to worry about any of those lines. Once I retarget my application, NuGet Restore will automatically pull up the libraries for .NET Core. And in my case, it is 100% compatible, so that means I can go ahead and port my application. And before I do that, let me show you the project file. If we go to, sorry. By the way, do you know how to open the project file in Visual Studio? How?
Unload it and then double
I need to, yes, unload the project. That's for old project files. First, I need to unload it. Then I do edit. And then I see this beautiful XML file. Amazing. Like, I'm still scrolling. And it has absolutely great parameters like those GUIDs. Very user-friendly, right? Just keep that in mind for my next demo. And let's go back to, sorry. Let's go back to my slides. All right. Before we go further, what is not supported, like a bitter part? What is not supported on .NET Core and .NET 5 and never will be? It's web forms, WCF server, Windows workflow are gonna stay only on .NET Framework. We could not bring them to Core, but we have alternatives for them. And we suggest looking at ASP.NET Blazor for web forms, at gRPC for WCF server, and there is an open source project for workflows. And for ASP.NET Blazor and gRPC, we will provide a migration guideline. So we are working on electronic book that will describe, like, if you worked with that technology, how easy transition to new technologies, which are very great. I took a look and I really like them. All right. Now we got our portability report green 100% compatible. That means we can port our application. Porting is very simple. It's updating target framework property in your project file from .NET Framework, in my case .NET 4.7.2, to .NET Core or .NET Standard. Depends on what you want to target. But there is a but. If you created your application in .NET Framework and you never touch your project file, you have old-style project file, the one that I showed you. And that project file doesn't know about .NET Core. So in order to port to Core, to be able to port to Core, you first need to update your project file to a new so-called SDK-style project file. And you can see how it looks. It's very nice, lean, much better to work with, but updating can be painful. And before, we had to do it by hand, so we released a document how to do it, and of course, there were many developers who were not happy with it, and they wanted a one-button click experience. Unfortunately, we looked at automating this problem, and we concluded we cannot automate absolutely all cases, because there are many different project types, there are many different nuances. So first, we thought we cannot automate it. We better explain people how to do that. We got feedback, please automate that. We responded that we cannot create like a Microsoft product that would work. It will be super buggy, probably like Microsoft products, but. And we got the feedback, well, automate at least something, because like, it's okay, you cannot do 100%, give me that 80% automation. I have 100%, I have 100 project files in my solution. No matter how trivial the update is, I don't want to do it 100 times. And then we created a tool, and we called it Try Convert. And that tool will try to convert your old-style project file to new SDK-style project file, and then retarget applicable applications to .NET Core. It will not touch your libraries. Your libraries will still target .NET Framework, so it will be up to you. Either you want to target .NET Standard or .NET Core. And yeah, for some cases, this tool will fail, and you will have to do it manually. Actually, when I announced that Try Convert tool, my friends reached out to me and told me what other Microsoft project we should have called Try something. That is being a Microsoft. So with that, let me show you how this Try Convert tool works. So try-convert is a global tool, and I installed it on my machine. So then I can call try-convert help, and there is a very few parameters. You can specify -p and pass to your project, or -w pass to your workspace. You can also specify MS build pass if you want to, and you can not do any conversion, but just do diff only, so the tool will not actually port, just tell you if it's able to port or not. And by default, because porting is modifying your project file, we create a backup copy. And we put that backup copy, it's your project file name .project.old, just in case you want to go back. But if you feel risky and you don't want that copy, you can specify no backup. Then responsibility is all yours. So I am gonna, let me, I already should have. Okay, I'm gonna type try-convert -p and pass to my project file. Now I'm gonna cross my fingers. Conversion complete. Huh. It's almost like I've done it before. Now Visual Studio tells me that file was modified outside of Visual Studio. I reloaded it. And now if I right-click and go to Properties, here I can see Target Framework .NET Core 3.0. So in my case, it was very easy. And now I can run it, cross my fingers again, and it should work. It should work exactly the same, because we just took all WPF, all WinForms, and ported it to Core. We have not started innovating in that area, so you won't see any difference. For you, it will be same experience, but you get all the benefits of .NET Core. And that thing works. Yay. If it didn't work for you, we have a step-by-step instructions how you can do it manually. And it's available at aka/porting to .NET Core. If you have any questions, if you struggle with your porting adventure, feel free to reach out to me. I'll be happy to help you. I'm available on Twitter. My coworkers joke that that's our primary work location, and then like Redmond, Microsoft, it's secondary, but Twitter comes first. When you port it, if you have some issues, but if you were good, you ran Portability Analyzer and you got 100% green report, those issues will be very easy to fix. You can fix them by simply adding missing libraries. And you can add exactly the library that you're missing, or you can add Windows compatibility package. That is a NuGet package that has over 21,000 APIs from .NET Framework, and we created it so you can still target core and use many things from .NET Framework. Some of those APIs are cross-platform, and some are Windows only. So you need to keep that in mind, but since you're developing Windows desktop, you don't care about cross-platform. Or maybe you do, but that's sad. If you're using WinForms chart control, you can add it as a separate NuGet package as well. It's called System Windows Forms Data Visualization. Does any of you use that thing? I was trying so hard to enable it as NuGet package. Fine, be like that. All right, and I don't even have a slide for WPF Designer because it's already there and it's already working. You can just go to Visual Studio and have a smooth experience of working with your WPF .NET Core projects. And WinForms Designer is slowly behind because we started work a few years, like WPF, we already had a prototype that we just reused, and for WinForms, we needed to start the work from scratch. So WinForms Designer is in preview mode. It's available in Visual Studio Preview, so if you're in GA, you won't see it. You need to install preview version, and then you make sure in Tools, Options, Environment, Preview Features, you check Use the Preview WinForms Designer. So right now, we support controls, base operations. We don't have data scenarios yet. We don't have third-party controls and user controls. That's what we're working on right now. And I hope by May this year, we will have somewhat solid designer experience, and we plan to complete all work related to designer by .NET 5. So answering your question, if you want, should you port to .NET Core or should you wait for .NET 5? For WPF, by all means, you can go ahead and port right now. For WinForms, that really depends. Do you want to use Preview Designer, or do you want a bug-less, or maybe like less buggy experience? Actually, Designer is pretty good. That's one thing that framework, WinForms Designer is pretty solid. So, and .NET Core will get there, but right now there are some bugs. If Preview WinForms Designer doesn't work for you, but you still want to port, you want to be on Core, there is a hacky ways how you can still use framework WinForms Designer in your .NET Core application. And that you can do by creating 2 projects and linking all files in both those projects. So you basically create one empty project and link all files to the other. One project will target .NET Framework, another will target .NET Core, and when you need the framework, you just work with .NET Framework project. When you need to compile for Core, you work with .NET Core. Another very similar approach, you have 2 project files side by side. One is targeting .NET Core, the other is targeting .NET Framework. You reload your application depending on what you want. Those are hacky ways, but yeah, just letting you know about all the options. And in the end, what we are planning for .NET 5 for WinForms. And nobody saw that yet. Not even my boss, we just put it together. So what we are thinking of doing for .NET 5 in WinForms area, besides the designer, which is our number 1 to 50 priority. We also want to add support for ARM64. We're going to work on high DPI improvements. That is like a big area for WinForms, and we are aware of it, and we are constantly working prototyping, but it will be some time till we finally get it all fixed. We are also thinking about adding new controls, or better to say, providing a wrapper around existing Win32 controls, such as task dialog. This PR is already done by our community member, and it's already in review state. Ribbon control, there are a few more Win32 controls, and WebView 2. We're also going to add latest Visual Studio, Windows, and .NET improvements, such as themes like color themes, etc., IntelliSense, IntelliCode, analyzers, and so on. And we're working on new accessibility requirements. We have that requirement WCAG 2.1, so we need to do some improvements to make WinForms more accessible. And of course, please give us your feedback. You can go on the WinForms repo, create a feature request if you need something in this area. That's the time where we are listening to you, and we form our roadmap based on what we hear and what we see in statistics and feedback and so on. So if you want something, please let us know. And with that, that's all I have for today. Thank you very much.
Thank you. So, big thank you to all 3 of our speakers, to Luce, Isaac, and Ulia. Right, there are a couple of drinks out there which are open and paid for. You are welcome to drink them. You have as long as it takes for me to square away my equipment, and then I'm kicking you all out of the building. So if anyone wants a very rapid drink, dive out there and get drinking. I think we're probably going to be heading to a pub nearby, or does anyone know where the NDC hotel bar is? I heard rumors of people there. So if anyone wants to stick around for a drink, wait downstairs, see what the plan is. If not, thank you very much for coming. See you next time.